Long ago, inside a vast digital kingdom, information filled every corner of existence. Images, sounds, words, numbers, and human behavior flowed endlessly like rivers. But hidden inside the chaos were patterns nobody could fully understand. So humanity created a new civilization, machine learning. Its mission was simple: teach machines to learn from data themselves. The first learners believed the universe could be explained with simple relationships. Linear regression drew straight lines through chaos to predict the future. Logistic regression guarded the gates of classification, deciding yes or no, true or false. For a time, their elegant mathematics solved many problems. But realities soon became far more complicated than straight lines alone. Deep in the computational forest lived the decision trees. At every branch they asked questions, splitting reality into smaller and smaller worlds. But individual trees were unstable and easily fooled. So thousands united together as random forests and gradient-boosting armies. Wisdom no longer came from one learner, it emerged from cooperation. In the mountains lived algorithms that understood space itself. K-nearest neighbors judged identity through similarity and distance. Support vector machines searched for the perfect boundary between worlds. When reality became too tangled, kernels opened hidden dimensions where separation became possible. The monks realized geometry itself could become intelligence. Some algorithms explored without teachers or labels. K-means searched for natural communities hidden inside data. Discan discovered dense civilizations surrounded by isolated outliers. Meanwhile, dimensionality sages compressed gigantic realities into forms humans could finally visualize. Patterns began revealing themselves even without answers. In the probabilistic temples lived the Bayes priests. They believed nothing in the universe was truly certain. Every decision became a probability shaped by evidence. Naive Bayes made surprisingly powerful predictions using remarkably simple assumptions. The priests proved uncertainty itself could become a source of intelligence. Then came the Great Neural Revolution. Inspired by the human brain, artificial neurons connected into massive networks. Each individual neuron was tiny and weak, but together, millions formed systems capable of learning astonishing complexity. The age of neural intelligence had begun. The networks grew deeper and more powerful. Convolutional neural networks learned to see patterns inside images. Recurrent neural networks and LSTMs learned to remember sequences through time. Words, speech, music, and motion all became understandable to machines. Layer by layer, machines learned increasingly abstract understanding. But eventually, even memory networks struggled with enormous information. Then transformers introduced attention. Every word could suddenly observe every other word directly. Machines no longer processed information step by step, they understood relationships globally. Attention reshaped the entire civilization of artificial intelligence. Some learners trained not through examples, but through action and consequence. Reinforcement learning agents explored environments seeking rewards. Every success strengthened behavior. Every failure became experience. Through endless trial and error, machines slowly learned strategy, control, and decision-making. At the frontier of the kingdom lived the generative dreamers. GANs competed against themselves to create increasingly realistic worlds. Diffusion models transformed pure noise into detailed images and imagination. Machines no longer only recognized reality. They began generating entirely new realities of their own. As centuries passed, the algorithms discovered a profound truth. No single method ruled all problems. Some mastered probability. Some mastered memory. Some mastered geometry, creativity, or exploration. Together, they formed a giant ecosystem of intelligence. And the kingdom of machine learning continued evolving endlessly.